All right, so in this week's video, we're going to continue on in section 9.1. And if you guys remember last week, the simplifying trig expression, some of you guys were confused. You emailed me. It's like, where do I simplify to? Do I just factor it? Where do I stop? And so this week, you will kind of see where all this is leading to. And it's really about verifying trig identities. And let me just give you some guidelines before we go over the 8 examples I have here for you. So first of all, remember a trig identity is an equation that's true for all variables on both sides of a trig equation. It's true for all variables that's within a domain. And guideline number 1 is that you can only work on one side. Okay, so typically I recommend you pick the more complicated side. If both sides look equally complicated, then you can work either side, but you're only allowed to work one side, which basically means you can't start cross-multiplying. Remember, you have to verify that it's true first before you start cross-multiplying, okay? So you cannot do that, no cross-multiplying. And the solution is typically not unique, meaning if a student decides to do the left-hand side of the equation and another student decides to do the right-hand side of the equation, and you end up verifying it correctly, then that works as well. Okay, so basically there's more than one correct way to verify trig identities. Okay, so guideline number 2 is to use all the trig identities you've learned, right? The Pythagorean identities, you definitely have to know, reciprocal quotient identities, which some of you probably haven't memorized already, and you're gonna have to substitute and convert. When all else fails, sometimes what I like to do is just convert everything to sine and cosine if possible. And this is probably the most important one, right? All your algebra skills that you've ever learned, adding, subtracting, rational expressions, simplifying complex fractions, multiplying by conjugate, factor, etc. Okay, so this is what often makes verifying trig identities difficult for students for the first time they're doing it, because they need to know all their algebra skills, all their trig identities, and then they have to manipulate. Now, for some of you, this might be kind of interesting and challenging because, in some ways it's like a puzzle, but it's an algebraic puzzle, okay? So I know not all of you are interested in algebra or math for that matter, but that's what makes it a little bit difficult. You kind of have to apply all these skills all at once. So I'll start with some easier examples, and then we'll go into some more complicated ones. All right, so let's take a look at this first one. Verify the trig identity. You may only manipulate one side. So right off the bat, right, you could deduce that the left side of the equation is definitely more complicated. So, I mean, there's not much we can do here on the right side. And so, if your algebra skills are strong, right, you can recognize that this is the pattern of A plus B times A minus B, right? And A plus B times A minus B, recall, okay, is just A squared minus B squared. So that's your sum and difference pattern, right? So if I were to multiply it out, this would be cosecant squared theta minus cotangent squared theta. And I would just write, question mark. Does it equal, right? We'll just write quotation. Okay, so cosecant squared minus cotangent squared, well, that is actually one of your trig identities, right? So another recall, that 1 plus cotangent squared theta is equal to cosecant squared theta. Okay, so cosecant squared minus cotangent squared theta, right, is just equal to 1. So even though this is not written directly as this, you can manipulate your trig identity to make it look like this. So now cosecant squared minus cotangent squared is equal to 1. I can finally say 1 is equal to 1. Oops. And I'm done. Okay, so again, sum and difference pattern, multiply it out. Cosecant squared minus cotangent squared, which we know is 1. Left side is equal to right-hand side. Sometimes they use this notation, LHS, which stands for left-hand side, and RHS, which stands for right-hand side. Okay, so a simple example number 1, using your sum and difference pattern, using one of your Pythagorean identities. Okay, moving on to the next one right here. Again, this one looks like either side could be more complicated than the other, or not either side is more complicated than the other, I should say. And so, as I mentioned here above, right, sometimes it's helpful to convert everything to sine and cosine. And I'm only going to manipulate the left-hand side throughout the whole process, okay? Can I do the right-hand side? Yes, you can, but I think the left-hand side might be a little bit easier, okay? All right, so tangent theta we know is sine over cosine. And cotangent, right, is the reciprocal of that. That's cosine theta over sine theta. And again, I don't know what this equals, so I don't know why I put the quotation marks here in the beginning. Just write equals, okay? You can't say this equals this just yet. Okay, now, this is where you have to learn how to add fractions, right? You're adding rational expressions. So these are unlike denominators, right? You have to multiply this by sine theta and sine theta. So let me show you all the work. And to get common denominators, right, multiply by the missing factor, cosine theta and cosine theta. Okay, so this step right here, hopefully you guys should not be overwhelmed, right? This is just adding fractions. In other words, recall, right, what's 1/2 plus 1/3, right? I have to multiply this guy by 3 over 3, 2 over 2, and then add. So likewise, same concept. Okay, in my numerator, I'm going to get sine squared theta. In my denominator, I'm going to get cosine squared theta, right? All over, right, the LCD, which is sine theta, cosine theta. Okay, now, remember, sine squared plus cosine squared theta, right? That is your Pythagorean identity number 1. That just equals 1. Okay, so where are you going with all this? Well, somehow this guy right here needs to look like this. And it almost looks like this, right? You can use the splitting up the fraction rule, right? You could rewrite 1 over AB as the product of 1 over A times 1 over B. Right? You could split this up like this. This only works if you're multiplying, okay? Don't try to make up your own rules. Again, that's where students make mistakes, okay? So I'm going to rewrite this as 1 over cosine theta times 1 over sine theta, right? This is the same as this. Now, what's 1 over cosine, you ask yourself? Well, that's secant theta. What's 1 over sine theta? That's cosecant theta. And you are done. Left-hand side is equal to the right-hand side. You verified this trig identity. Okay, so notice all the algebra skills, right? I have to know how to add fractions. I have to know how to split up fractions in a way that does not violate any algebraic rules. Okay. All right, so moving on to problem number 4. Again, on this one right here, I would say it looks equally difficult on either side. You can definitely work on the right-hand side, still arrive the left-hand side, but I think that to do this problem, the easier way is to manipulate the left-hand side. So just like the previous problem right here, you know how I convert everything to sine and cosine? I'm going to do the same thing for secant and secant. Okay, so this is already cosine, right? So secant, you know, is 1 over cosine. And secant down here is still over 1 over cosine. Again, don't cross multiply, okay? You're not allowed to do that. Once you stick one side of the equation, you have to work on that side throughout the whole process. Okay, so you have a complex fraction, and I taught you guys how to simplify complex fractions back in chapter 6. Multiply top and bottom by the LCD of cosine theta, 1, and 1. So multiply top and bottom by cosine theta. Distribute. This times this, you're going to get 1. This times this, you're going to get cosine squared theta. Cosine theta times 1 over cosine theta, you're going to get 1. And you have now 1 minus cosine squared theta over 1 plus cosine squared theta. Well, we're almost done, right? This side almost looks like this. Well, 1 minus cosine squared, that's just sine squared. In fact, we are done with verifying this trig identity, right? We have the left-hand side equal the right-hand side. Y is 1 minus cosine squared equals the sine squared. Again, just a quick recall. Sine squared theta plus cosine squared theta is equal to 1. If I do 1 minus, right, 1 minus cosine squared theta, right, this expression is the same as this expression. All I do is move it over, and I substitute it. 1 minus cosine squared is sine squared theta. LHS is equal to RHS. Okay, so let's finish up the last problem on this first page. Now, on this one right here, number 5, notice the first 3 problems, I did the left-hand side, left-hand side, left-hand side. Is that always going to be the case? No. On this one, specifically, I'm going to, just on this problem, I'm going to do the right-hand side. Now, you're like, how the heck do I make the right-hand side look like this? Well, remember I said one of the algebraic strategies that you've learned, right, is to multiply by the conjugate of either the numerator or the denominator. All right, the conjugate just means switch the sign here in the middle when you have 2 terms. And so on this problem, I'm going to multiply by the conjugate in the denominator. And I'm going to say multiply by 1 minus sine x. Okay, so I could have written an extra line just to copy down the original problem, but I'm not going to. Okay, so in your denominator, right, you have a plus b times a minus b, right? And we went over this. It's just a squared minus b squared. So this is 1 minus sine squared x. In your numerator, right, notice you have a 1 minus sine x quantity squared. Okay, so all your algebra skills, right? How do I FOIL a binomial? Don't say this is 1 minus sine squared x, right? You have to square the first term, which is 1. This term times 2, minus 2 sine x. And then square the last term. It's going to be positive. Okay, so from this step to this step, there shouldn't be any difficulty in terms of new concepts introduced, right? You know, in the past, right, maybe you had, you know, I don't know, x minus 3 over x plus 2, right? If I multiply top and bottom by x minus 2, right, I would get something like this, except now we have trig functions. Okay, so you pick the right side, Mr. Zhu. Now, how the heck is this going to look like that? Well, one step at a time. In my denominator, 1 minus sine squared x, right? Again, just like what we did over here, right? Except this previous problem had 1 minus cosine squared. Well, 1 minus sine squared is just cosine squared x. And that's all I'm going to do. I'm going to actually rewrite this line one more time. And now I'm going to split up the fraction. Okay, so here's my algebra skill that I'm going to write down here. Recall that if you have a plus b over c, you could split it up as a over c plus b over c. Okay, plus or minus. So what I'm going to do right now is rewrite this as 1 over cosine squared x. Now on this one right here, right, minus 2 sine x over cosine squared x, right? But remember, I could also use this splitting up the fraction rule like this. So I'm actually going to write it like 1 over cosine x, sine x over cosine x times 1 over cosine x. Right, so again, all I did was split this up. And then plus sine squared over cosine squared. Okay, so splitting up the fraction rule, students have trouble with that because this is, you're allowed to do this, right? But you can't do it the other way around, okay? So do not do this, okay? C over A plus B is equal to C over A plus C over B. This is not true, all right? So don't get these two confused. All right, so I split up the fraction. Now, what's 1 over cosine squared x? You're like, where are you going with this? Remember, it has to look to the left, look like the left-hand side. Well, 1 over cosine squared, that's secant squared x. What's sine x over cosine x? Well, that's just tangent x. What's 1 over cosine x? That's secant x. What's sine squared over cosine squared? That is tangent squared x. You're like, my goodness, this looks really, really messy. How does that look like this? Well, now this is actually a perfect square trinomial, right? The square root of this is a perfect square. The square root of this is a perfect square. The product of this and this times 2, that's just a minus b quantity squared. In this case, this is my a, this is my b, right? Parentheses squared, parentheses squared. This is now secant x minus tan x quantity squared. And I verified the right-hand side is equal to the left-hand side, which is this. Okay, so lots of algebra skills involved in this problem, right? You know, if you're having trouble from this first line to this line, I bet a lot of students had trouble splitting up the fraction, right? And then you have to recognize that, hey, this is a perfect square trinomial. Now it has trig functions instead of, you know, x squared minus 4x plus 16, right? Remember, you had a factor that, or I'm sorry, x squared minus 8x. Right, if you had to do something like this, right, recall, I mean, this is just x minus 4 quantities squared. Okay, so all your algebra skills need to apply, and like I said, that's what makes it challenging. But, you know, if you have strong algebra skills, this still may be a little bit difficult because sometimes you just kind of have to spend a little bit of time, and it's okay to erase and, you know, try something else if it doesn't work for the first time.